An important bit of information regarding graphs is the domain of the graph. When you're working with piecewise functions, there's two ways to determine the domain of the graph. There's looking at the graph, so graphically determining the domain, and then there's using the definition in order to determine the domain. And in order to do that, you're going to be looking at your restrictions, but we'll get there in a moment. When you're looking at it graphically, what you want to consider is what is the lowest x value that your graph is going to approach or reach. And in this case, our graph is going to continue forever into the negative infinity for the x's. So we know that our lowest value for domain is going to be negative infinity. You will never put a bracket on your infinities, whether it be positive or negative. That is very important to remember. So in order to find our highest value that we're going to approach, so the ending point of our domain, we're going to go from the left, and we see that we continue forever into the positive infinity as well. There are no breaks in our graph, and there are no completely ending points. This line continues on forever this way, just as this piece of the parabola continued on forever into the negative. Therefore, our highest value for our domain is going to be positive infinity. In order to determine it based off of the definition, I like to do number lines. So if you consider the first definition, which says that x is greater than 3, it's all numbers that way, from 3 inclusive. We also have a restriction for at 0, and it's less than not included. But we also have this bit here where it says we're also including everything in the middle, and due to this definition, we now include 0. So we also include all of this. With that in mind, we continue on forever into the negative infinity and forever into the positive infinity with no breaks in between. So based off the definition, we can again say that the domain is negative to positive infinity.